So today onwards we'll deal with ninth class physics, okay, and chemistry also. So today's chapter is third chapter, that is atoms and molecules. So in this chapter we have a first very important concept, that is nothing but law of conservation. Of conservation of mass. Okay, this says very simple thing, that is when law of conservation of mass says when a reaction happens, if you consider sodium hydroxide, that gets reacted with a HCl. HCl is nothing but an acid, right? We got a sodium chloride and water. Wonderful. So if you consider the reactant side and the product side, in the reactant side what happens is, in the reactant side, okay, we'll take 20 grams of both the cases, right? And we know there is a formation of water, that too in 30 grams of water gets formed, and you just forgot to note what is the value, okay, how much amount of sodium chloride gets obtained, right? So the law of conservation of mass says the total mass of substances before the reaction is equal to the total mass of the substance after the reaction. It says the total mass of the substance before reaction. So these were called reactants. So 20 plus 20 is 40 grams is the total mass of the substance before reaction, is equal to the total mass of the substance after reaction. You need to get 40 grams, right? But here 10 minus, right? So simply add 10 here, we will get 40, right? So from this law of conservation of mass, we simply add and subtract some of the values here. Clear? So this easily says something, right? So let's deal with one activity now. Let's say we'll take a glass bottle now. Okay. Inside the glass bottle we'll take vinegar. Okay. When vinegar, we'll take a 20 grams here. When vinegar is made to add with a balloon, okay, let's say this is a balloon. Balloon contains a baking soda. What it contains? Baking soda. Okay. When these two gets reacted with each other, okay, before the reaction we just weighed it. It says this is 20 grams, this is 10 grams, and glass bottle is 10 grams. Overall 40 grams might come here, right? Wonderful. So overall 40 grams, right? Before the reaction, because we haven't mixed baking soda with the vinegar. Yes. But when we just mix the baking soda into the vinegar, what happens is there is a reaction happens between the vinegar and the baking soda. There is a liberation of gas happens. That gas is nothing but a carbon dioxide gas, right? So the balloon gets inflated. Wonderful, right? But if you observe the weight still remains the same, right? But within a fraction of a second, I just remove the remove the balloon. Now I simply observed that there is a decrease in the value, that is 40 to 38 grams. Oh, why this happened? Because that 2 grams weight belongs to the gas, which is nothing but carbon dioxide gas, right? So before removing the balloon, we just observed something, that is before and after the reaction 40 grams and 40 grams were the same. Yes or no? Yes. But when we remove the balloon, okay, gas get escaped easily. Yes or no? Yes. So from this is also one of the example for law of conservation of mass, right? So if you consider next case, if you consider one more example, let's say we have what? We have a glass here. Wonderful. And that glass, inside that glass we'll take some amount of camphor, okay, and we are going to weigh this, okay. I think the glass and camphor overall weight is 20 grams, let's say, right? So we'll put something over here, like something like a plate or something to not escape. When it is burned, what happens is there might be escape of gas happens, right? So we are not allowing the gas to escape from it. So we simply burn this by using the paper. Then we put a burning paper inside. This is going to burn, right? But the weight still remains the same, because there is a liberation of gas happens inside this, but there is no escape point for the gas, right? So the weight still remains the same, that is before and after the reaction were the same. When we remove the plate, what happens is the gas gets escaped easily. There might be decrease in the weight, okay, it might become 15 grams or something else, right? So those 5 grams belongs to this gas, right? So from this we simply say law of conservation of mass, which is nothing but the total mass of reactants before the reaction is equal to the total mass of products, right? So we'll deal with very important activity, that is 3.1, that deals with law of conservation of mass. Activity 3.1, that is nothing but about the law of conservation of mass, right? So in this we'll take some of the substances here, but they had given us very simple thing, that is nothing but we need to take 3 conical flasks. How many conical flasks we need to take? 3 conical flasks. 1, 2, and next one is 3, right? So you need to take 3 conical flasks here. In the first conical flask we'll take copper sulfate, right? We'll consider it as X, and sodium carbonate we'll consider it as Y, right? So when these two get mixed together, right? So let's say we'll take some amount of sodium carbonate inside the conical flask now. The weight of sodium carbonate is 20 grams, let's say, right? And imagine like this, and the conical flask is 10 grams, and we have taken a cork, okay? The cork is fitted inside before, when this test tube is filled with some amount of copper sulfate, and copper sulfate normally present in crystalline form. When it is mixed with water, it becomes an aqueous solution of copper sulfate, right? So 10 grams of copper sulfate is mixed, okay, and we put that thing and we put the cork, right? So if you consider, if you look at it carefully, that test tube is not mixed properly, okay? That test tube is not mixed inside the sodium carbonate, right? So the reaction doesn't happen. So before the reaction we just weighed it, and it becomes overall 20 plus 10 plus 10, overall 40. So it shows 40 grams now. Wonderful. When I stir the liquid, now what happens? There might be reaction happens, and it is going to mix it together, right? So in this case what happens is, when copper sulfate that is going to react with sodium carbonate, we got sodium sulfate plus copper carbonate, okay? Sodium sulfate plus copper carbonate, okay? This is the thing that is going to happen. But before, while mixing this thing with water, it becomes blue color. Wonderful. When mixed with the sodium carbonate, what happens is, there is a change in color, it becomes to pale green color, okay? And also this sodium carbonate, sodium sulfate and copper carbonate doesn't mix it together, and we got a precipitate. What? Got a precipitate. Wonderful, right? So, but we are not going to consider this overall equation now, but we are only considering about this situation. In this situation, if you consider it carefully, so this is 40 grams, right? The weight is 40 grams, right? Before the reaction it is 40 grams, and after the reaction also it is 40 grams, right? So from this, we should easily say it is also an example for law of conservation of mass, because before the reaction it is 40, and after the reaction also it is 40. So this is one of the example, and he had given us one more. Let's consider situation 2. In this situation we'll take barium chloride, and on the other hand we'll take sodium sulfate. Wonderful. Then we have taken sodium sulfate here, sodium sulfate Na2SO4 inside the conical flask, right? So let's consider it is also 20 grams now, right? The weight of the conical flask also 10 grams. And we need to take a test tube, and inside the test tube we need to take something, that is barium chloride, that is taken, and also that too in liquid form, that too in 10 grams now. Now if you weigh the liquid before the reaction, okay, so before the reaction you need to do something, that this test tube is going to be tied with a thread, and the thread is stuck with the rubber cork, right? So the weight becomes 40 grams now. Wonderful, right? So this is before the reaction, right? But then what you are going to do is, we simply shake the conical flask. Now what happens is, that test tube get moved upward, and the overall barium chloride get mixed with the sodium sulfate. Now what happens when barium chloride get mixed with sodium sulfate, right? We got a sodium chloride and barium sulfate, right? BaSO4, and but here chlorines 2 and sodiums 2, we'll put 2 here. So I think the equation is balanced, but it is also a white precipitate is formed. White precipitate formed, which means these two is not going to be mixed properly. So that is the reason there is a white precipitate gets formed in the bottom of the flask. But we are not going to consider this, right? We are only focusing on the weight, right? Here what happens is the weight before the reaction is 40 and after the reaction also 40. From this is also an example for law of conservation of mass. We'll move on to the last and final case. In the final case, we will take lead nitrate that is mixed with sodium chloride, right? So we'll take some amount of sodium chloride solution inside the test conical flask, right? So we'll consider it as 20 grams and we'll take a test tube, and inside the test tube we'll take lead nitrate here, we'll consider it as 10 grams, and this test tube just tied through the thread, and when it is closed, now what happens? It is not mixed, right? So when it is weighed, we got a 40 grams, simple, 20 tests, 10 and 10, overall 40 grams, wonderful. But after stirring it, what happens? The test tube goes up and that lead nitrate get mixed with the sodium chloride solution. Now if you look at carefully, when lead nitrate that gets reacted with sodium chloride, what might be going to happen was very simple. We got a lead chloride and sodium nitrate, right? We'll put 2 here and also we'll put 2 here. So 2Na, 2Na, 2Cl, 2Cl. Okay, 2NaNO3. Wonderful, right? Everything gets balanced, right? So in this case also what happens is lead precipitate is going to be formed. Okay, so this is not properly mixed. Okay, but we are only focusing on the weight, right, in this case. So the weight becomes still 40 before the reaction, and after the reaction also it is still 40. From this also we should simply say this is one of the example for law of conservation of mass, right? So this is very important question from this chapter. Okay, just focus on this and read well. Okay, thank you. Tomorrow we'll deal with law of constant proportion, right? We'll deal with this tomorrow. Thank you.